Hi there guys, it's Stephen here from the VT group of companies, and that is Vertitech, Acacia Engineering and Qualistat. The easiest way to find me is at energyexperts.ca, and that's again energyexperts.ca. So this week was a little bit of an interesting week, and I thought I'd have a quick chat about what I have discussed with a couple of clients this week. One was a friend of mine who was his daughter's house, and the other was actually my sister's home. So the bigger issue on both of these homes, very similar issues, so I thought I would have a conversation that would help you and help all other viewers as well, was talking about condensation on windows and what are some of the solutions. So one of these houses here in Calgary, the other house I'm talking about is on Vancouver Island. Obviously different weather conditions, but the issue is exactly the same. When we get condensation on windows, there is normally two reasons. One, our moisture level in the home has gone too high that we're hitting what we call dew point. Dew point is when the moisture falls out of the air, and that's that condensation that starts to form on your windows. So if we get to a point that the surface temperature of the window is cold enough and the humidity level, the relative humidity, is high enough, we're going to get condensation. So there's really two solutions to it. One, you change the temperature of the glass. How do you do that? You upgrade your windows. The alternative to this is to change the humidity. Well, let's start with what the cause of humidity in a home is first. So in a home, people give off moisture, pets, showering, cooking, bathing, all of those are giving off moisture. If you've got a fish tank, that gives off moisture. So one of the first things to do is try and control the relative humidity in the house. Make sure you're sitting somewhere in that sort of 20%. As it gets colder, you want to be able to drop the humidity. So one of the very, very first things is think about, have you got exhaust fans? Are you using them? We're going to talk about solutions to this in a bit, but think about where the moisture comes from. That's your first step, is where is the moisture coming from in your home? If you have showers running and bathroom fans aren't running, you're going to get moisture. If your dryer is venting to the inside of the house, you're going to have excessive moisture. If you're drying clothes into the house, it's going to have lots of moisture. You've got an excessive number of plants, you're going to have lots of moisture. So if your humidity levels are high, you really need to find a way to control those humidity levels. If you're having humidity problems, think about getting yourself a hygrometer, which allows you to measure the humidity in the home and helps you understand what those humidity levels are. So if you're looking at this video and trying to think about what to do about it, look around and say, what's causing the humidity in the house? For the record, outside air leakage is doing exactly the opposite. A house that's well sealed was one that will end up with lots of humidity. A house that leaks like a sieve does not tend to have high humidity because outside air tends to dry. So the symptoms are you get condensation, it forms on the glass, it runs down, it settles on your windowsills, causing window rot, makes them look ugly. Sometimes you can get mold. That's some of the symptoms you've got from that. In some worst case scenarios, particularly in colder climates, you can get lots of ice formation. So what are the solutions? Okay, so we identified the problem. Next thing we want to do, identify solutions. Well, as I said, first one, let's control the moisture inside the home or the relative humidity inside the home. And how would we actually do this? One, turn on bathroom fans. Use kitchen exhaust fans. Make sure you're using the appliances that you have in the house to exhaust air out to the outside when you're creating high humidity. So if you only have one bathroom exhaust fan, it's probably not sufficient. You should have one per bathroom. You should have a kitchen exhaust that exhausts to the outside. That is taking the moisture out of the home. Make sure your dryer is correctly vented and ducted to the outside. Don't dry clothes inside the house. But we can get a little more creative on how we can control these and solve these problems on an ongoing basis. So let's talk about that bathroom fan. One, make sure you have a working bathroom fan. You want one that ideally is even controlled off what we call a dehumidistat. So a dehumidistat means it measures the humidity in the bathroom. When the humidity goes above a certain level, it will turn on and will run until such time as the moisture in that bathroom has dropped. You can use it put it onto a timer is an alternative way, or you can just leave it on for longer periods of time. But my recommendation is let's do this from a controls point of view. There's quite a few manufacturers. I've dropped a link in in here and a photograph of one. It's called a dehumidistat, not a humidistat. It's a dehumidistat. It does the opposite to a humidistat. You can even get fans, and I put an image in here of one that you can get that actually has the dehumidistat built right into the fan, and that will turn on and off automatically. So you don't even have to worry about installing the dehumidistat, just changing the fan. The humidity in your home could actually be coming from your own humidifier. I guess that could have been one of the causes. So think about if you have a humidifier. In both cases of these two houses I was looking at this week did not have humidifiers, so that was not the cause of the problem. However, we can't ignore the fact that a lot of people have humidifiers, and what you're meant to do is adjust the set point on your humidistat. This is the humidistat, this is turning the humidifier on. The dehumidistat is to reduce humidity. The humidistat would turn the humidifier on when the humidity drops below a certain level. You want to manage your humidity in the house, so you want to be able to have a humidifier, as in adding moisture at certain times, and dehumidifying, but not through a dehumidifier, but just through the dehumidistat, which controls the exhaust fan. Ventilation air is perfect for doing the drying of the home. Now, what I was saying with the humidistat, you want to control the humidity based on outside temperature. I'm here sitting in my living room talking to you on a really nice February day. It's about 5 degrees above. Today, there's no issues with having too much humidity. We're probably sitting about 35–40% humidity in the home. Not an issue whatsoever. I've got triple pane windows. I'm not going to have any condensation. However, I've got hardwood floors in here that I want to make sure have a nice humidity level so they don't crack. I've got the furniture, I've got paintings. I want to make sure that the humidity levels are not too dry either. But as it gets colder, and we will get colder, when we get to that -20, -30 and lower, we're going to have to drop the humidity set point inside the house to match what's happening outside. That's the best way to do it. You can do it manually. A lot of the humidistats have a controller on them. So either you adjust it down manually, alternatively, hook it up to something like an Ecobee thermostat. You know I love my Ecobee thermostats. I think they're a great technology, and they will do that for you. They go and look at the outside temperature, and they adjust the humidity based on outside temperature. It's called an ambient reset humidistat. One of these homes only had one bathroom fan, and the other problem was the bathroom fan had a little 3-inch duct to the outside. So first of all, the ducting was too small. The humidity wasn't going out the house. When you buy a bathroom fan, make sure it's got a decent CFM. Look at the sound level. You normally want something like a 0.3 zone level. It's a low sound level, so it's not annoying you to have it run for long periods of time. And it will run because you've got the dehumidistat control. In other words, you want to reduce the humidity. That's the sort of control that you want. The other thing, if you go and look at the installation manual for most fans, the diameter coming off the back of the fan might be a 3-inch. They normally recommend that you upsize it a minimum of 1 diameter. So in other words, if it's a 3-inch, you would go to a 4 might go to a 5. You want as fewer restrictions in the ductwork as possible so the air is going to the outside. Do not ever vent your fan directly into the attic. You're going to cause all sorts of other problems. It must be vented to the outside. Make sure it's also installed in accordance with manufacturer's literature by upsizing the ductwork by normally 1 minimum number of bends. Try not to use flexible ductwork if you can, rather use rigid ductwork, and make sure it's got a good backdraft damper. So it's a quiet fan, got the right size ductwork directly to the outside. Make sure it's bigger ductwork than normally directly on the fan. The next thing you want to do is interlock that. If you've got a 4-stair system, like my client here in Calgary, she's got a furnace, so interlock that with a furnace. So when that is on, the furnace fan is on, and this will give us a negative ventilation system. Better yet, have this wired all the way back to the thermostat, or a switch next to the thermostat, which is what we call a ventilation switch. You can turn that on, run your fan for a long period, your furnace for a long period of time, which gives you the drying and gives you good ventilation, interlocked with the exhaust fan, and the two run at the same time, and that would ventilate your home and give you fresh outside air. Why do I bring this up? Because it also takes the moisture out of your home and controls that humidity. So ideally, you want to be able to control your fan from a switch, let's say your summer switch, or that's what some people call it, or just a ventilation switch somewhere that's easy accessible, normally near the thermostat, and then that would be interlocked with the furnace. So the furnace would come on at low speed and would mix the air, and there's lots and lots of reasons. I've had this conversation numerous times why you want to run that furnace fan in low speed or in continuous mode to keep moving air, better humidity control, better filtration, and better air movement. So by doing this, you're controlling the moisture, you're getting rid of moisture, you're drying the air out by having this ventilation. That's what you need to do. Again, if you are going to, in this case, one of these clients' cases, they're going to add extra insulation to the attic. Do the fan before you do the attic insulation. No contractor wants to walk around in 18, 20 inches of insulation. So make sure you put the fan in before you actually, and the ductwork before you do the insulation of the attic. The next thing to control is the temperature of the glass. So if we've controlled the humidity inside the home, which is great, we've stopped getting too much moisture, we're getting moisture out and we're drying it, which is fabulous. The next thing was, I said at the beginning, you've got to think about how do you control either the temperature or the humidity. We've been working on the humidity as a big component of this. The next piece that I want to talk about is the temperature of the glass. Well, there's really only one way to do that, and that is to upgrade your windows. So by putting a better quality window, triple pane window ideally, so it's a triple pane window with a low emissivity coating, argon gas in between, that's going to give you a warmer surface temperature. Again, if we've got higher humidity, warmer surface temperature, we are not going to see that condensation. So make sure you think about upgrading your windows. It's not either all this or all that. It is a conversation of doing both in a lot of cases. So upgrading the windows to a better quality window. Don't forget the Green Homes program has a grant up to $250 per window. When you upgrade windows, improves resale value. There's a whole video I did on why would you want to upgrade your windows. Now, not everybody's got the budget to upgrade the windows, and I appreciate that. So control the humidity. Maybe do some windows now, some windows in the future. But if you do get condensation on your windows, make sure you keep it dry. The next thing you want to do is you might sometimes get mold buildup, and that's not unusual. Everybody gets that if they get condensation. Get rid of the moisture, and then go to CMHC. I'll put a link in the bottom here, the CMHC. They have a nice document on how to get rid of mold. Just clean it up. Dry it out, clean it up, and you can control the mold. It's not unusual to get mold, but make sure you're always cleaning it up and looking after your windows, and you'll get good longevity. And last but not least, there is another item that you want to consider. If you have a forced air system, like I do in this house, my client here in Calgary, you want to be able to run that furnace fan, spoke about it a few moments ago, on a more continuous basis, so you're getting air movement across those windows. So think about that. If you've got your furnace fan running more or less continuously, we'll talk about the Hoimi damper. Don't forget about that. There's a whole video I did on the Hoimi damper. Take a look at that video as well. But we want to get air movement across those windows because that's going to help it dry and keep dry. So even though it's cold, get that air movement running the furnace fan continuously through either the ventilation switch or through the thermostat, where you can control the amount of times that the furnace fan is running. Make sure, for example, when you drop your blinds, maybe leave a little gap at the bottom because that's going to allow air to move over those. Open the blinds as much as you can. The other thing that you want to do is keep interior doors open so your house has got lots of air movement around them. What you find in certain rooms, particularly when people are sleeping at night, there's lots of moisture. If the doors are closed, you don't get the air movement around the house, and therefore you can get higher humidities in those areas, and that creates more condensation. So hopefully that helps you on those. In the one case here, look at the image on this one glass window that we've inserted. This is a double slider, where it's actually 4 panes of glass. This is fairly typical for older homes here in Calgary, but they are all around. Calgary gets a lot colder than other parts of Canada. You've got 2 panes of glass and a gap, and then another 2 panes of glass. These windows actually don't do a terrible job. They're really old, but moist air gets in between the 2 panes of glass, condenses as it hits that outer surface, and that whole window frosts up and you can't see through it at all. So really those windows need to be upgraded, and that's going to make a significant difference. So the reason that's happening is because you've got warm, moist air. It's getting between the 2 panes of glass on the first layer, gets in between the next 2, condenses against the outer layer, which is very cold, and frosts up and waits for it to warm up before when it warms up next time, and then melts away. So this is going to be cyclical. The problem won't go away continuously. Unfortunately, best way to deal with this is sealed units. And that's my next point. Sometimes you will have windows where you get between the 2 panes of glass on a sealed unit. Windows are actually sealed units, triple or double pane. Sometimes those seals fail. It does happen. It's not the end of the world. Just replace the glazing. Easy enough to do. I do want to give a shout out here to a company called Basco World, and that would be Basco, B-A-S-C-O world.com. Simon was the guy who was working for me on one of my projects. He did an absolute fabulous job, and we actually upgraded on one project all the windows from double pane to triple pane where we had extra space in the frame. These were wooden windows, so there's an option, is to upgrade the glazing. Now, specifically if you're taking a glass sealed unit that failed, think about upgrading to triple. There may be space, there may not. If there's no low E, no argon, put a new sealed unit in that has low E and argon. So the one in Calgary I was dealing with this week, the windows we tested them did not have a low E coating, did not have argon gas, but the sealed unit had failed. Just upgrade that one piece of glass, but make sure it's one with a low E argon coating. And again, please I suggest going to bascoworld.com, talk to Simon. Now, even if you're not going to replace windows completely, think about upgrading glazing. If you've got a broken pane of glass, upgrade the glazing. There are options. But if you're really looking at a full upgrade to your home, think about going triple low E argon, Energy Star rated windows, and go and look at my video that I spoke about on windows, improved comfort, aesthetics, resale value. It's going to help you a lot. So make sure you're upgrading your windows. The other thing is, as you tighten up your house and people are becoming more and more energy conscious, and that's fabulous. You may have had a blower door done. You're going to find that the humidity levels will increase the more you seal the home. That's called home as a system. You get these different things happening as you tighten up the home. So don't be surprised that you may need to run bathroom fans more, use those controls I was talking about earlier. Okay, the other option, which is a little more expensive from a ventilation point of view, think about an HRV, heat recovery ventilator. This is a much more expensive item, but they're really nice systems. It ends up exhausting air to the outside, but while it's doing that, brings outside air in. The outside air coming in dries it. It's not a dehumidifier, it's a heat recovery ventilator. I'll do a whole new video on HRVs in the near future. Watch for that, or just do some research on HRVs or heat recovery ventilators, and that could be something you could consider for drying out the house. In both these cases, particularly the one in Calgary, I would say wasn't necessary the perfect recommendation for today, but as the house gets better sealed, this may be something to go with in the future. And I did discuss with her how you could do it and do a simplified install. That would be a consideration. HRV would help dry out the house. In the house of my sister's house, maybe if the humidity continues to be an issue after dealing with moisture, dealing with windows, hey, something like an HRV and giving good ventilation in the home might be something worth considering. The problem a little bit in that case would be that she would require a fully ducted HRV. So now it's running ductwork, a little more complicated, but this will give that good indoor air quality. We all want those healthy homes, so think about maybe an HRV, even though that's got an electric baseboard, potentially going to heat pumps, but this will certainly help on the ventilation side, so you don't have to open up those windows. You want to keep them closed and deal with the proper ventilation. Keep those interior door open. I just want to remind you, first thing, control the moisture in the home. Where's it coming from? That's your absolute first. Bathrooms, kitchen, when you're cooking, where's the moisture coming from? Maybe it's a structural problem. Think about that. And if you're really having an issue, you can get hold of us at Qualistat or at Energy Experts, and we can do some testing to help you. We can actually put data loggers in and see when the humidity goes up, when the humidity goes down. Make sure that you understand how that works. The next thing is, now you know where the moisture is, you know how to control it. You want to raise the surface temperature of the window. So that's changing to a brand new window, or windows plural, double low E, triple low E. That's what I'm recommending, triple low E argon. And then getting that air movement by running the fan on a continuous basis. And that's that idea of having a control switch that interlocks the exhaust fan and the forced air system, i.e. furnace, so things are running on a more regular basis and you continue to get that air movement. Healthier home, better filtration, better humidity control. So let's quickly head down to the basement. Let's go and have a quick conversation about, just as a reminder, around the Hoimi damper and what it does, and then we'll wrap up on this conversation. So again, my name's Stephen. I'm from Vertitech or VT Group of Companies, and you can find me at energyexperts.ca. Again, energyexperts.ca, and hopefully you're finding these little videos useful. So if you've done an energy evaluation, this is something I've done to broaden the scope of knowledge. down in the mechanical room, and I've just flipped the camera the other way around. So we're looking at the ductwork on a forced air system, right? So if you please go and look at my Hoimi damper conversation, we'll talk about that in great detail again. But there is that duct there, the one that is in plastic. That's a vapor barrier to stop condensation forming. That goes from the outside in, and you can see it at the back there. That comes all the way in, and then connects into the return air side of the furnace. There's connecting into the return air side. As you can see, that if I look at the furnace, on the left-hand side is my return air. So when the furnace fan is running, what is happening is there's a negative pressure in that ductwork. Outside air will be drawn in. Outside air will be drying out the house. If that is interlocked with your bathroom exhaust fan, what that means is air is being exhausted to the outside. Outside air is being brought in through this duct, and that is going to help ventilate. That's fresh air. That's good for your health. But it is also going to help with the drying and keeping the moisture levels under control. So there is your fresh air from the outside, goes into the return air. You run the fan. If you've got an ECM motor, go and have a look at my video on furnaces, and talks about different types of motors and different ways to operate them. That's what you want to have a look at. As you can see, this one does have a humidifier. This one has its an independent control, which I did on the return air side because it couldn't hook up to my Ecobee on this house. But I do strongly recommend go and have a look at Ecobee, go and have a look at the ambient reset. That's what you want to do. Okay, so just closing off on this one, as a reminder, this is a Hoimi damper. Hoyme. There's a whole video I did on Hoimi dampers, and what would you use this for? This would go into that return air, or so that cold air return, that fresh air, whatever you want to call it. That's where that would go, and that would minimize the outside air coming in when the furnace fan is not running. You can control it different ways. So please go and look at my video on Hoimi fresh air intake makeup air dampers. So energyexperts.ca is my best place to reach me. The VT group of companies, which is Acacia Engineering, Vertitech, and Qualistat. There's all information on all of those about similar subjects. Please go and have a look at us, energyexperts.ca. If you are looking at replacing windows, don't forget to get your energy assessment done, because there are government grants. If you have problems with moisture in your home, attic rain, anything like that, that's a Qualistat side of things, and that's what we're here to help you with. So again, my name is Stephen. Thanks for watching me today, and hopefully you're enjoying these little YouTubes. Hello and welcome back to our YouTube channel. Energyexperts.ca is the website. My name is Stephen. Hopefully we've chatted previously, and if it's the first time viewing us, you might find a whole lot of information that is useful for you on your home, how to keep it comfortable, energy bills, things like that. So please watch us on YouTube, share the channel, like us in the like button. My name is Stephen. I'm the owner of Vertitech. You can find us at energyexperts.ca. And today I've been asked to do a little bit of a conversation about how do you keep a basement warm. So if you've got a house that's maybe only got one furnace, and how do you keep the basement warm? So a lot of our clients who've had energy evaluations done, they've asked us to sort of expand on the options you have for making basements a little bit warmer. And let's get going. So I'm here in my home, which is a 2-story back walkout home. And we're going to sort of just have a quick look around and talk about the house. So if you can see behind me, you'll notice that we've got the upstairs, that is the second level. This is also a back walkout, and this house has one furnace in it. So when I moved into this home, one of the challenges we had was the basement was really, really cold compared to the rest of the home. So one of the first things that you would consider is, where is your thermostat? So let's have a look here. I'm just sort of going to pan around, and you can see from behind me, there is my Ecobee thermostat. So as you'll notice, that's in the center of the house. It really doesn't have a lot of relevance to the temperature in, let's say, this room here, which is my living room. We don't have any real indication what's happening there. And then if we went down into the basement, you'll see that behind me, we would have the same problem. Basements tend to be cold. But we have the same issue if you go upstairs. You also don't end up with a really good representation of the temperature throughout the home. So what we've done on this house is I've done a couple of things. One is I have a number of these. These are remote sensors from the ecobee thermostat. Again, it's a remote sensor. It's got a motion detector built into it. So what happens here on a case like this is when we go back to the thermostat, that there has multiple sensors attached to it. So one, it's measuring the temperature in the living room, it's measuring the temperature in the basement, and it's measuring the temperature on the second floor. So with this type of system, I can program the temperature sensor according to how I use the house. So on the main floor, this sort of pan around, you'll notice this is my main floor. I want that temperature to be comfortable during the hours that I'm using it. And normally when I get home from work, that's somewhere in the region of 5:30, 6 o'clock until about 9 p.m. in the evening. Sorry, maybe more like 10 p.m. in the evening. So that becomes my control point. The second time, or the second set point is in the evenings when once my wife and I go upstairs to bed, we would then want the temperature to be more controlled based on the second level and the master bedroom. So again, I have one of those sensors in the bedroom, and I set my schedule up so that the second floor becomes controlled on a sensor later in the day or later in the evening. In the basement, I have another sensor, so when I'm down there, it picks up the motion detector, knows that I'm down there, and then will try and control to that. What you can also do is you can have it set that it averages the temperature between all the different sensors. You can have multiple sensors throughout the home. So one of the first things I would suggest considering when you've got cooler areas in the home, get yourself an ecobee thermostat. This is what's behind me here. Make sure you've got a number of sensors that go on with that. Make sure you can program to how you use the home. They have motion detectors built into it. So in a way, it's like having a thermostat in your pocket that, in other words, the temperature follows you around the home or gives you an average temperature. The other one is on the controls on the thermostat, set your furnace fan to either continuous operation or long periods of time. I think this one's set 50 minutes every hour, so it's got long periods of time that the fan is running. Why would you do that? Well, if I've got hot temperatures on the second level, or hotter temperatures on the second level, colder temperatures in the basement, by having the furnace fan run on a more regular basis, I end up in a position that I have more even temperatures. So I've got a better filtration, I get better humidity control, and I get more even temperatures throughout the home by running that furnace fan on a more continuous or ongoing basis. Again, if you've got a newer furnace, you want to have an ECM motor or a high performance, high efficiency motor, and that means it's not going to cost you a whole lot of money. The other thing that I'd recommended is, and we speak about in one of the other videos, go and look at the Hoimi damper video that talks about make sure that damper is closed when the furnace fan is running and there's no heat on. That's the next thing, but go and look at the Hoimi damper video that talks about how do you control the outside air. So this is good for ventilation, but you get that mixing of the air, you get better humidity control, better filtration as well. So that will help you in your basement. And then the last thing, or the other thing that you should be doing before we get into more expensive upgrades, is considering what we call air balancing. So if we do a bit of a walk around, let's just focus on the main floor here right now. At the entrance, we have a floor register in the room where we started in. Behind me, just near the windows, we'll have some floor registers as well. Here we've got a floor register on that side here. Obviously, we've got near the window, that's where we get most of our heat transfer. If we walk over, we'll have another one down here. Again, that is a supply register. You can see that if we go a little closer, you can see the supply register on the floor. And these are all throughout the home. So we can just walk around. I'm not looking at the return air, I'm looking at the supply airs. You've got them mostly under the windows is the best place to find them. Ensure that you don't have any furniture blocking those, so you can control the heat and the amount of air coming through. The other one that you want to think about is look in your kitchen, look in your bathrooms. You have what we call kick plate heaters. So you'll notice under the kitchen sink here, there we have a kick plate heater. So there's the supply for the kitchen. That one's also got a damper on this. So what you want to do is you want to look at those, find all of those in the home, and make sure that you've balanced the air. So for obvious reasons, those that are closest to the furnace are likely to have the most air coming out of them. If we go upstairs, we can do the same sort of thing. But if you think about the distance from the furnace, for example, let's go into one of the bonus rooms, one of the rooms that is above the garage, but also probably the furthest away from the furnace. So you can see the register in the floor in here. So what's going to happen is that's possibly going to get the least amount of air. But the other thing that's happening in this room, we've also got an exposed wall. I've got an exposed floor, which means it's colder floor, colder walls, and a ceiling. So this may need more air than other areas of the home. So that's that air balancing, right? So you can control the amount of air using the dampers in the floor registers, kick plates, and areas that are sort of further away, but exposed floors will need more air. So in regards to the basement, what you want to be able to do is drive more air down there if possible, but in summer and winter they'll be different. And let's just explain why that would happen. Your thermostat, which we're talking about here on the wall, is going to be one that is registering the temperature on the main floor. But if you haven't got those remote sensors of the Ecobee, you're not going to be able to measure the temperature in the basement. The main floor is getting some nice sun and it's warming up, but the basement is not reacting to the ambient temperatures. Therefore, it won't turn on the heater because the basement's cold. So what you want to do is have some way of knowing what the temperature is in your basement. So once again, you'll notice we've only got a single furnace that does the whole house. The other thing that I have done, now we get into the more expensive options, is if we walk over, you'll notice that I have a combi boiler. This is a Navian combi boiler. It's running at a 95% AFUE. This is a combi boiler. In other words, it does my domestic hot water. It also does my space heating as well. And therefore, I will have the opportunity to eventually put some baseboard heaters down here in the basement. So there's my basement. This is a walkout basement. You'll notice in a typical basement, you've only got ceiling registers. There's a couple of registers in the ceiling. There's one over there. Here's another one that we have here. But we have no way of changing the temperature dramatically in the basement, and it doesn't get affected by the sun the same way as the main floor. So eventually getting to more expensive options would be to look at putting baseboard heaters, radiant heaters, separate heat source down in the basement. I do not recommend putting electric heat. Electric heat is 100% efficient, but the electricity is an expensive energy, so rather try and use your main heat source if possible, particularly if you're in the Alberta, Saskatchewan market. Think about a natural gas-fired boiler, a combi system that would give you independent heat into your basement and independent control. Hopefully this was help you in regards to colder basements and trying to keep them more comfortable. Again, my name is Stephen. Please find us at energyexperts.ca. If you're looking at doing some of these upgrades, you want some in-home consulting, please make sure you contact us. We can get a energy consultant out to your home, help you do the energy evaluation, and walk you through the process of any of the government grants. And as most of you now know, there are grants galore. There's the Greener Homes program, there's programs in Edmonton, there's programs in BC, there's programs in Ontario. There are lots and lots of programs out there. Watch out, CMHC is coming. CMHC has a new one coming out as well. Not a grant, but it's a loan program. Watch for that as well. So there are lots of incentives to help you make your homes more comfortable, save or reduce your greenhouse gas emissions. And we're going to do a video later this weekend on utility bills. We know they're all going up, and we'll talk about how do you control those utility bills. But this is the time to upgrade your home. Contact us at energyexperts.ca. And you know what, if you've got friends and family who've got basements you're trying to help them with, please share this video, like this video, and hopefully this was helpful. Thanks for watching. My name's Stephen. I'm from Vertitech, energyexperts.ca, and good chatting to you. Well, good morning. My name's Stephen. Thank you for joining us on this YouTube and training video. We're here today to help you understand a few different things, and I've done these to help people understand how these mechanical systems work, about the Greener Home program. But today we're going to specifically be talking about how the ventilation system works in most homes, and in particular about the fresh air intake. So I'm at a home here. We're going to go down to the mechanical room. We're going to have a look at how the fresh air intake is connected. Why is there fresh air intake? Maybe different ways to improve the energy efficiency of the home by controlling the ventilation system. So what we're going to do is we're going to talk about what is fresh air intake, why do we have it, and then look at the different choices. So if you had an energy advisor in your house, he's probably spoken to you about this already, and this is really just to expand on that information. So let's start off having a look at what is a fresh air intake. Let's just flip the camera around. Okay, so what we want to have a look at here is this is the fresh air intake from outside. Let's have a quick look at what we can actually see. As you can see, the opening from the outside there has got spray foam to make sure it's well sealed. What we're specifically talking about today is that fresh air intake. That's that pipe duct. If you get a better look at it there, that is the duct that has the plastic cover on it. You can see it's a 6-inch diameter fresh air intake. Okay, so fresh air intake meaning outside air comes into your home. The other duct adjacent to it, this one here, has a supply air register. That's a supply air, and this comes into the return air side of the ductwork. Because it's on the return air, there's a negative pressure in the ductwork, and therefore this will be bringing outside air in because that duct where it goes into is in the negative pressure. But let's have a quick look at the furnace itself. That's the back side of the furnace. On the right hand side is the supply air. That's where the humidifier is connected to. You can see the supply air comes off, and then on the left hand side that is the return air, and in this case the humidistat has been connected on the return air because that gives us a better average humidity of the home. So not a bad place to connect it. The alternative is to connect it to something like an Ecobee thermostat, which has a ability to adjust the humidity based on outside air temperature. So that's called an ambient reset. The other thing that I'd like to point out while we're here, you can see most of the joints on the ductwork have been sealed with a foil tape, not duct tape. Duct tape will dry out and come loose. And why? Because we want to get the heat to where we want it. But that's not really what today's whole conversation is about. What we want to talk about today is about how do we control that ventilation air and the fresh air coming in. Again, if you've had an evaluation done by one of our team at the VT Group, either Vertitech or Acacia Engineering, they would have discussed this with you. And I just want to really reinforce the knowledge that they have passed on to you and expand on that. So I'll be back now. I just want to talk to you from the other side of the camera. Okay, so here we are, we're back now, and I'm going to get a chance to actually chat to you a little bit. So why do we actually care about the fresh air intake? So one of the things we almost always recommend is running that furnace fan, maybe not continuously, but on a regular basis. The furnace fan should be controlled from the thermostat. You can put it on a schedule. Why would we want that? The idea is if we're mixing the air in the house, we bring in more, we're moving air around, we get better filtration as it goes through the return air. It gets filtered every single time, but you also get more even temperature throughout the house. The house I'm standing in right now is a 2-story back walkout, 1 furnace, which means we need to mix it so we don't get that stack effect that creates different pressures and temperatures without the home. Mixing it up, running it on a more continuous basis. So if you're thinking about a furnace, and we're going to talk about furnace as a totally separate conversation, make sure you get one with an ECM motor. That's a motor that will use a little bit of energy, but it runs slowly and it mixes the air all the time. But if you're going to do that, think about what's going to happen. We were showing you earlier on about that return air that was there. That's always under a negative pressure if the furnace fan is running. So what you can do is you can get something like this, and this is called a Hoime damper. What I mean by that is, or that's the manufacturer on that is a guy out of Camrose. Cliff Hoime is the guy who makes these. I'm sure there are other brands out there as well. But this is a Hoime make-up air damper. We're not talking about the combustion air damper. We're talking about the make-up air damper. So what this does, this is wired such that it's connected to the furnace so that when the furnace heating system is on, the damper opens up. So there the damper is in normal open position. They can order them different ways. But when the heating is on, and only when the heating is on, you would be able to open up the fresh air damper. That means fresh air would come in from outside that we were looking at earlier. Fresh air comes in from outside, goes through, gets heated up, and doesn't show up as cold air. The problem with running the furnace fan almost continuously is that when the heating is not on, you get this cold air coming through your registers because it hasn't been preheated, it's just being mixed. It is actually a code requirement today on any brand new home. They must put in one of these dampers. It is a requirement today. So if you've got an older home that hasn't got in, I would recommend when they're doing a furnace upgrade or you're doing some maintenance or even draft proofing on your house, think about getting a Hoyme, that's H-O-Y-M-E, make-up air or fresh air intake damper. That's what these look like. I would actually recommend mounting it closer to the outside. This one here would be closer to the inside, and this would only open when the furnace fan is actually heating. So that meets code requirements, gives you the fresh air when the fan is running, but when you're just circulating the air, the damper is closed. How does this tie into the Greener Home program? Well, one of the things that is in the Greener Home program is draft proofing, air sealing, call it whatever you want. And one of the things is when we do a blower door test, which is part of the services we offer, is the Greener Home program grants, is when we run a negative pressure test with the blower door. As it stands now in this house without this damper being installed, we would measure that as air leakage. However, once that is installed, that would actually close that off, and that only is air leakage, which is not air leakage at that moment, when the furnace fan is running. So it is closed whenever the heating system is off. So you would measure that as also air leakage improvement. So one is going to make your house more comfortable. It's going to save your energy. It's going to allow you to run those furnace fans on a continuous basis, which we strongly recommend to be able to do, and that will help you. So think about a Hoyme damper, think about your fresh air intake, understand the concept of bringing it in when you're heating it up. It's going to get the other thing. There is other controls you can do with this. You could, in the summer months, connect this to a temperature sensor for outside. So when it's cooler outside, you can get some free cooling. It's just a different way of wiring it. So we'll do the exact same thing that we're talking about right now, that when the furnace fan is on but no heating is called, no fresh air is coming in. However, you have either a switch, which could be a manual switch, or a thermostat that says you want some cooling in the house, you can allow fresh air in, and that would be great for places like Calgary, places that get cooler maybe in the evening, and you can take advantage of free cooling. So one more time, just to recap, this is your fresh air intake. It's a Hoyme, H-O-Y-M-E damper. They're manufactured right here in Canada. They don't sell them directly from the factory as far as I know, but feel free to go to their website, talk to your heating contractor. It's going to help you on draft proofing or air sealing. It's going to make your house more comfortable, and I strongly recommend that you run your furnace fan on a more regular basis and have those controls. In a little bit in one of our other videos, we're going to talk about furnaces and selecting of furnaces, and by having that ECM motor and running it on a more regular basis, that's part more of a furnace selection. So if you already upgrade your furnace, you may just need the damper. If you haven't, when you talk about furnaces, do this at the same time. So once again, thank you for watching my videos. Again, this is the VT group of companies. One of the easiest way to find us is energyexperts.ca. This ties into the Greener Homes program. Hopefully this will help you there. Go to our website, energyexperts.ca. We're part of the VT group, which is Vertitech, Qualistat, and Acacia Engineering. Qualistat is a building envelope and consulting company. Have a look what they do. We've got some great videos there with Daryl, which shows you things about attic rain, other things that you may want to know about your home. Signing off again, please watch our YouTube channel, and thank you for watching. And my name's Stephen from Vertitech. Cheers.
Hey guys, this is Daryl Paul. I'm with the Qualistat Building Performance Consultants here in Alberta, and I thought this was a good opportunity to talk about condensation and frost on windows, because it is extremely cold outside. So if you're getting a lot of condensation and frost on your windows, what's the cause? Well, one of the causes could be the relative humidity within the building. So down here you can see we're at 35% relative humidity. That's the maximum design humidity for winter under the National Building Code. So the building code says that's the level that we should be able to operate a house without having problems. But that's not the level where we won't have condensation or moisture on the windows. For instance, if you look at the window here, on my double glazed window, I have some condensation on there. There's no frost, but I have condensation. Over here on the triple glazed windows, these are a PVC vinyl, but on the triple glazed windows, you can see I have very little moisture or condensation on there. And one of the main reasons is it's only 35%, and these windows will withstand that, but I also have the supply duct right there, and it's not blocked by anything. So the air can freely flow in this area. The blinds are open so that the heat and the air movement can keep the humidity away from that window. Now, if we go back to here, one of the ways that we reduce the relative humidity, and you can see it here, it's at minus 23 outside, 64% relative humidity. So what that means is that air is bone dry outside. So how do I know? Well, if I take that air, take my app here, and I punch in outside temperature minus 23, humidity outside 64, and I warm it up to room temperature, see right there, it's 2.7% relative humidity. So that's bone dry air. So once it warms up, it has lots of capacity to absorb moisture. So let's look over here at the thermostat. Now right now I don't have the HRV on, simply because it's at 35% where I want it. When I turn this on, this is going to exchange indoor humid air with outside really cold dry air. But what that'll do is it'll circulate the air within the house and it'll make it feel cold. So I turned this off, but what I did do is this is set for 23 degrees Celsius. That's the set point. Inside it says it's 23 degrees. So if I look over there, that says 22 over there. But remember, this area on the exterior is going to be colder because it's so cold outside. So what I do here is I run the furnace fan on. If I turn this to auto, maybe you can hear that the furnace fan kicks off because it's not calling for heat. The fan's not going to run. So I turn this to on. So now this is just circulating internal air. This is off, so it's not bringing cold air in, it's just circulating this air. So what I'd like to do is I like to forget that number, set it to a comfortable temperature, turn this to on. So now it's circulating the air throughout the house, moving it around, and that air, which is 23 degrees at the thermostat, is reaching the exterior surfaces to warm those up. Because what will happen is if I set that at 23 and I turn this to auto, before I know it, those surfaces over there are going to be 16, 15 degrees, and around the window, the stagnant air is going to be even colder. And if the stagnant air gets cold enough, then I'm going to start to see a lot of frost or condensation form on those windows compared to what there is now. So I want to make sure that this is set to on, and it's circulating the air so that the air right there, which is 23 degrees, 35% relative humidity, can reach past and at the glass and at the frame and at the exterior surfaces. And that improves the comfort in the house. It feels so much more comfortable. But if you're having condensation on the windows and you can't reduce the humidity, then perhaps it's your ventilation system that's not performing correctly. But not having sufficient insulation around the rough openings or having too much air leakage isn't going to cause that problem. It's actually, if you had air leakage through here, because the air outside is so dry as it comes in, it removes the moisture. Remember, as we change the relative humidity here, as the temperature goes up, relative humidity goes down. So if you had lots of air leaks, missing insulation, these windows are actually going to be drier than what they are now. So there's an indication, if you're having moisture on the windows, reduce the humidity. Here's another point too. If these are metal windows, aluminum frame windows, you're going to have to keep your humidity way down. You're going to have to keep that humidity down at around 20% on a day like today at minus 23, because they just can't hold it. There's just not enough there to prevent moisture from forming on those surfaces. So those are some tips on reducing condensation and frost and moisture on the windows. So if you're having excessive amounts, make sure the windows are open, make sure the air can flow up near the windows, the fan is running on manual constantly, and if you have to reduce the humidity, then pop this switch on and turn on your HRV, and that'll help reduce it, especially when it's so cold. So this is just an update to yesterday's discussion on condensation in windows. This morning it's quite a bit colder than it was yesterday. We've got a minus 29, it was minus 30 just a minute ago, with 58% relative humidity. The wind speed is quite high, so the wind chill outside is minus 45. But when we look at the calculation for relative humidity, if I take that air that's minus 29 and warm it up to 22 degrees inside, I'm at 1.5% relative humidity, so super dry air. Today I've kept the humidity down a little bit, 29%, but you look at the windows, we've still managed to maintain the amount of humidity to a level that it's not really accumulating on the windows too much. We're keeping the fan on, and over here on the glass where there's double glazed, you can see just a little bit of moisture. So managing the moisture on the windows by keeping the humidity just a little bit lower today. And even though it's minus 29 outside with a bit of a strong wind, we're not having too many problems with the windows. Hope that helps.
Well, good morning. My name's Stephen. Thanks for joining us and joining our YouTube. This information is for our wonderful clients that help do the energy evaluations. Those people want to understand a bit more about windows. There are government grants out there for people who are upgrading their windows, and that's what we're going to talk a bit about today. But we're going to have a bigger conversation around windows and doors and make sure everybody understands the reason behind them. So I've come to a house here today where we're going to look at different choices on how do you upgrade windows and why would we upgrade windows in a home. So this house we are today is a 1990 home, so you can see where there's a lot of windows, lots of big windows in this home, and it is time to think about, when your home's getting older, to think about upgrading different windows. So we're going to go around and have a walk through the house, but at the same time we're going to have a big conversation around the government grants. We're going to have a conversation about, sorry, let's get into the home first, about the government grants, about reasons for upgrading windows and different choices that you have. So now that we've got into the house, and if you have a look around, I'm just going to do a quick spin, you'll notice that there's lots and lots and lots of windows. Okay, this house actually has 37 windows in it. It's 1990, fairly typical for the era, but there's one area in particular I want to sort of take you to, and that's the living room area. And you'll notice that behind me, you'll see that there's some really big windows, a very big window behind me here. That used to be a very cold and uncomfortable area. And then the other area I want to touch on is this area here of the home, which is I call it the turret. If you have a look at all of these windows, this is true both on this level and upstairs, but there are lots and lots of windows in the home. So again, 1990, the windows that were in this home were some Gino windows with the swiggle bar, which had failed. So one, they were as ugly as anything because you had the moisture going between the windows. And secondly, they were really uncomfortable. So this area here we are, which is in the kitchen area, was so cold and uncomfortable you really couldn't enjoy the space. We had the same thing happening when we went to the master bedroom. Again, you'll see the same sort of configuration. Let's head up quickly upstairs. So why would somebody think about changing windows in a house? One, I had windows that had, let's say, failed. The swiggle bar had failed, got moisture between the windows. And for that reason, it was, they were really ugly. But the other one was, again, let's have a look quickly at the windows on this area. Look at the amount of windows. So you can only imagine how cold and uncomfortable this area was. We upgraded the ceiling insulation, all of that, but we still had an issue with comfort. So why do we replace windows? Firstly, comfort. In my case, energy efficiency, or say comfort, was probably the driving factor for me to upgrade my windows. That's one of the main reasons I would do windows. Other reasons, aesthetics, makes windows look nicer, better from a resale value point of view. And then obviously there's energy efficiency as well. So windows are more energy efficient. There's lots of reasons to choose different types of windows or different types of glazing. So some of the factors that you need to consider, one is what we call the U value, which is ultimately the insulation value of the window. And you have to hit certain targets to be able to qualify for the government grants. That's the Greener Homes program. So click the link at the end of this video. There are lots of information, energyexperts.ca, on what the grants are, and we're going to discuss those briefly today. So look at ER number, that's the energy rating number, is another one, which is an overall performance of the window over a heating season. Does it lose or gain more energy? So you have to look at that as well. You've got other factors as well. There's different coatings like low E argon, also low E coatings, Argon, krypton is another gas. What does the argon actually do? It slows down this transfer of energy from inside to outside. So it really does help the window to perform better. So there's a gas that goes between the two panes of glass. It's typically going to be argon gas. The newer, more high performance windows don't use air anymore. It's argon. Krypton is another one if it's a narrow space window. So typically a 1/4 inch spacing window would use a krypton gas. You've got your low E or low emissivity coating, and that coating is a coating on the glass, and there's lots of selections. You've got to think about which way do the windows face, the performance of the window. So you've got for north facing, south facing. You don't want to overheat your building either. So then you've got another one called visible transmittance. How much natural light is actually going to get in through that window, and what does it look like? So that's your visible transmittance number. Have that conversation with your window guy, making sure that you get some good visible transmittance. And the other one is called solar heat gain coefficient. That's the ability of the window to let energy in. It's between 0 and 1. You want to be able to let that energy in, particularly here in Canada, where we do have a colder climate. We want that energy in, but we need to provide some shading. So a good solar heat gain coefficient is really, really important so that we are able to let the energy in, particularly in the winter months when the sun is low in the sky. You get some good shading, or say deciduous trees, they can give you the shading in the summer months, but allow the sun in the winter months is another consideration. So we've said change windows, environmental, better from the environment. Change windows because it's going to make your house a lot more comfortable. It's going to reduce the sound coming in from the outside. You're going to reduce condensation on your windows as well. You're going to have a better house to sell. So there's some of the main reasons to think about upgrading your windows. So what the government has done is they have also come out with a government grant that will help pay some of the additional costs. They're not going to pay for all the window costs. But if you're buying a window and you have a U value that is 1.22 watts per square meter per degree Kelvin or better, you can get $125 per window. And that's, when I say per window, we're talking a rough opening. So each one of those holes behind me is a rough opening. So remember, it's $125 per rough opening if your window is 1.22 U value or better. Or you could look at it as an ER number, and the ER number has to be better than 34, my apologies. 34 or above gives you an ER number. If it's better than that, you get $125 per window. If you want to go to the higher performance window, which is what I would recommend, you need to have a U value of 1.05 or better, or should I say not an and, or a U value of 40 or better. And there is $250 per window. If you're doing doors, you can also do an Energy Star rated doors. All the windows must be Energy Star rated. Please remember that all windows and doors must be Energy Star rated to qualify for the government grants, and they are per rough opening. On the door side, if you have a U value for the door of, again, 1.22 or better, then it would qualify, or an ER number of 34 or better, then you would qualify. So make sure you're talking to your window company, making sure the window they're installing does meet those criteria. They must be on a list. You can find them if you go to our website, energyexperts.ca. You can find our link to the government grant program, and you can understand what all of the different options are. But all the windows that are to qualify a grant, it must be on the list, and it must meet these criteria. So, giving you lots of reasons to think about changing windows. There are a few other things I want to touch on in a few moments, but make sure you get your energy assessment done before you do the window upgrade. That is absolutely critical. The government grant program, the Greener Home program, does require an energy assessment in advance and an energy assessment afterwards. So go to energyexperts.ca and you can find us there, and you can book your assessment through energyexperts.ca, and that's through the VT group. We'll talk about the different companies in a bit. So what have I done on this house? So this is why I sort of decided we should talk about this house. I've gone for triple low E argon windows on this home. It changed everything about the home. The furnace doesn't run as often on a short cycling. It's way more comfortable. I've got a 2-stage furnace in this house. I don't get the condensation. I used to get so much ice buildup on my windows. I've spoken in some of my other videos about making sure that the humidistat is correctly controlled. You're controlling the humidity based on outside temperature. Again, that's Ecobee tied to your humidifier. which is then tied to outdoor reset. So it's an ambient reset humidistat and change the humidity accordingly. But that paired with triple pane windows, well installed, made sure they're airtight and sealed. That's where we use the blower door. Make sure your contractor's doing a really good job to draft proof those windows. So look at all the benefits that you get by upgrading windows. Comfort, resale, aesthetics, less ice on the windows or less condensation on those really, really cold days. So think about upgrading your windows. Hopefully this helps you make some decisions. Don't forget that there's some rules that NRCan has. This is very important. Please don't ignore what I'm just about to say. There's 3 ways you can prove you've met those criteria of those windows. 1, leave the label on the window. Don't take the label off the window. Leave it on until the advisor has come to the home. Sometimes people don't like that because they want to take it off the window and makes things look a little bit better. Sure, I do understand that. But in that case, you must take a photograph of each window as it's installed and a photograph of the label on that window for every window that was replaced. So again, as a homeowner, you're allowed to do this. As a contractor, you can do this. Again, let's go through that one more time. If you want to take the labels off, you must have a photograph of this label plus a photograph of the window with the label on per window that's been replaced, and that is sufficient way to prove that you've met the criteria. Obviously, as long as they met those U values and ER numbers. Please consult the NRCan guidelines. Go to energyexperts.ca, look for the tables, look for the links to the Greener Homes program, and you can make sure you've done that. There is an alternative way and a third way, but that is on your invoice from the window company, the NRCan reference number must be listed on the actual invoice that window meets the NRCan, and that proves it's on the list. So windows must be on the list. They must meet those criteria. There's no ifs or buts. And if you do that, then you would be able to qualify for those grants. So you're getting lots of reasons to upgrade windows. As I said, I've done triple low ER on here. I guess the other thing before I close off on this one is to talk about is that if you're going to spend any money on windows, why not go the best you can? You're not going to do them again in a hurry. You want to make sure that you've dealt with that sound, the comfort, the moisture. The whole home is just so much better because you've done it. Once you've spent the money, you've already spent most of it by doing the windows. So go for the best you can right from the beginning is my recommendation. Again, let's just look at this living room here. You can see this large window. The comfort levels that have been improved by doing the glazing or the change outs on these windows is absolutely fabulous. I don't get the moisture. It's a much better house and much more comfortable. And oh, by the way, I can see through them. We're not with the condensation. So thanks for watching my video. Again, please make sure you go to energyexperts.ca. My name is Stephen. Hopefully this helps you out. Hopefully you've had an assessment done. Don't forget to get your follow-up done when you've done all the upgrades you want to do. You're going to see improvements in both air leakage. You're going to see improvements in so many respects. If you haven't done an assessment, you're thinking about doing windows, go to energyexperts.ca. You can look to that's the part of the VT group, and the VT group consists of 3 different companies. Vertitech, which is an energy consulting company, Acacia Engineering, which is a mechanical engineering company that helps with energy consulting. We also do residential energy assessments there as well. And the third one is Qualistat. So Qualistat is a building envelope company. There's a lot of great information on that website. Please go and look at theirs. Subscribe to Qualistat as well, where we deal with attic rain, we deal with moisture, we deal with helping homeowners operate their homes better, but mostly on the problem side. Lots on the new home and existing home. So again, thank you for watching. My name's Stephen. Please subscribe, watch our videos, and hopefully this was useful. Energy Experts, that's plural, .ca is probably the best way to reach us. And thank you for watching. Hello and welcome to the VT Group or Energy Experts YouTube channel. Today I want to chat to you a little bit about hydronic heating and combi boilers and zoning. So again, my name is Stephen. I'm from the VT Group of companies. You can also find us at energyexperts.ca. So we're an energy consulting company. We're also a mechanical engineering company. And today I want to talk a bit about hydronic heating, that's heating with hot water, how this can help you with your basement, how this can help you keep your house warm. But I also want to talk a bit about temperature control and zoning. So hopefully you've watched a bunch of our videos. If you're interested in what we've done and what we've some of our other videos that we've done, please share those, like us on YouTube, and let's get the message out and let's talk about how we can help you. So what we do is we are an energy consulting company, as well as mechanical engineering and building envelope, but to want to talk mostly about the mechanical and energy management. So we try to help homeowners like yourselves understand how to make their homes more comfortable. So if you look in the background, I'm actually at my office here. This is one of our demonstration facilities. We've got a hydronic heating system. So what the advantages of hydronic is, hydronic being hot water, in this case glycol, it allows you to do zoning. So in other words, you can provide heat to various areas of the home at different times with different controls, and we'll look at some of the control strategies in a little bit. So this is a hydronic heating system. I'm going to turn the camera around and I'll walk you through what some of the items are. So now what we want to talk about is what is it that we have on the wall behind me. So we've just got the camera flipped over so we can go through what the system is. Let's do sort of a bird's eye view of what we have. Over here we have a Aldi's, is the manufacturer. This is a ERV, this is an energy recovery ventilator. We'll talk about that as a separate video. But remember, go and have a look at what Aldi's is and go and have a look at what they do. This has got a ZRT or zone control. This is almost always what we recommend when it comes to residential evaluations. But most of what I want to do is focus on, for example, the Vesta combi boiler. So what is a combi boiler? This one does both domestic hot water heating and space heating. So one more time, this does domestic hot water, it's like an on-demand tankless, but it also does space heating. So this is our entire heating system for this building. There's a combi boiler, it does domestic hot water, and the hydronics on this one's a little more complicated. We've got it as a demonstration unit, but we've got a circulation pump. This is a Grundfos circulation pump. And then from there, we've got things what we call fan coil units. We've got baseboards and we've got in-floor heating. So the space where I'm standing in right now, we have many of these different features. The in-floor heating is where you bury the tubes in the concrete. If you have a look carefully down here, there's the tubes that are running into the concrete. These are run probably on a 16-inch or a 19-inch on center. And we've got water running through those, or glycol running through those at about 140 degrees. So it's also got what we call an ambient reset, so it will adjust the temperature of the water based on outside air. That's called an ambient reset. We'll talk about why. I want to make sure you understand these in full detail. The other technology we've got, so we've got the in-floor heating there that goes in the concrete, heats the floor up. These are controlled with Tecmar thermostats. There's one Tecmar thermostat on the wall there. This system was put together by Viper Mechanical. Thank you, Dean and Viper, for this. Done a fabulous job. But let's talk about some of the other things. In-floor heating is one way to heat the space. The other one is we have radiators. So if you go look at some of my other videos, you'll notice I talk about doing a combi system with in-floor heating and or radiators. So these radiators can help with heating different areas of the home, like baseboards. So now we're back here, we're talking about other ways to heat your home. So this is what we call a fan coil unit. So a fan coil unit is like a furnace. The only difference is on the fan coil unit you've got hydronic. There's a hot water coming in, there's a hot water going out that goes through, and we heat the air kind of like a typical forced air heating system. And you can see the size of that's an iFlow. So please go and have a look at the link below and go and have a look at what an iFlow is. This often replaces a furnace, and we'll talk about tying this all together in a nice little bow later. Here is our control system. Please don't be overwhelmed about what's there. These are all our zone valves. So as you can see in this scenario here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different zones. This is all Tecmar controls. Okay, so remember I just spoke about we having 12 different zones, and I want to now have more of a conversation. How do we use this technology? Why would you put a combi system in? Again, we saw we got a force flow, that was the iFlow. That's like a furnace, it's like a radiator in your car. You've got the in-floor heating, which is in the area I'm standing in here, where we heat the floor, typical for basements, can be done on main floors, second floors, etc. Great to go under a tile. You've got the radiator, which is great for basements. and then you've got the different zones. So in every one of those zones we were just talking about, those allowing you to have a different thermostat for each one of those zones, which allows me to control the house in so many different ways and different temperatures throughout. So I love my hydronic heating. It's the best way to go if you get the chance. Think about hydronic heating. But most of you guys who are watching this video are talking about a retrofit. So what would you do? This is very similar to what I've got in my house, and we've spoken about this. We wanted to go look at some of my other videos. What I would suggest, if you've got a cold basement or a cool basement, this is one of those bigger, more expensive upgrades. Think about getting rid of your hot water tank once it's come to the end of its life. Think about putting in a combi system, which means you can do domestic hot water and you can do space heating with it. And then you can put radiators, in-floor heating. In-floor heating is a little harder to do as a retrofit, but you can do some staple up, which goes under the tile in certain areas of the home. And this one gives you domestic hot water, it gives you zone control. You can put multiple radiators. You can break your basement into different ways, different areas, so you can heat them up at different times. So it gives you lots and lots of independent control. So think about if you've got a cold basement, you've got to really want to upgrade. When you do that, think about going to a combi boiler with some zone control, with radiators. Think about maybe even changing out your furnace to a forced flow or a fan coiled unit, and that will give you your different forced flow. You could add air conditioning to it as well. The last thing I want to talk about, and this, I have a specific client that we were talking to last week, where if you've got hydronic heating, you can only get so many BTU per square foot out. It's normally about 35 BTU per square foot is the maximum you can get out of a hydronically heated floor. So one of the first things you need to do is make sure that you know how much heat loss is coming out of that room. If it's more than 35 BTU per square foot, your hydronic heating probably won't be sufficient. But if you can get around 35 BTU per square foot or less, then your hydronic heating can actually make the world of difference and give you the heat you need for that space. The next thing you want to do is, obviously, if you've got concerns, you've got hydronic heating but you're not getting enough heat, make sure that that pump is working well, make sure there's flow. You can use infrared thermography to find out that there is water going through each one of those zones. Now, if you've got a hydronically heating in the floor and you know there's heat and there's hot water flowing through and you're still not getting the control, have a look at your control strategy. Make sure that, one, you've got the right flow rate, but also that there are the right zone valves and zone controls that you control room by room, area by area. So it should be a balanced flow system. So think about this way. You can, when you've got zone control, you can control multiple temperatures, many different thermostats. Tekmar is one of the biggest control brands out there. Go and have a look at their website, and that's TEKMAR. Look at the link below. Look at a forced flow combination system such as the iFlow. Think about radiators. We showed you a few radiators, and think about in-floor heating. And these are really, really good ways to either retrofit a home or to, when you're building a home, think about these different technologies. So again, thank you for watching. Hopefully this helps you if you're looking at hydronic heating or hot water heating, thinking about upgrading, improving your basement temperatures, thinking about zoning and temperature control. Hopefully this gives you some guidance on this. Again, my name's Stephen. You want to find more about the different technologies, the Greener Homes program. If you need an assessment, give us a shout. Energyexperts.ca, or VT Group is the other one. Go and look at the different YouTubes we've done. Go to Qualistat, have a look at Acacia Engineering. Thanks for watching. Please like us, share this with friends and family if this was any good to if this was useful to you. Again, energyexperts.ca. My name's Stephen. Thanks for watching, and we'll chat to you soon. Cheers. Good morning, everybody. My name's Stephen. I'm here from the VT Group of companies, and that is Vertitech, Qualistat, which is a building envelope consulting company, and Acacia Engineering, which does mechanical engineering. We had a home here. We often use this house as one of our show homes to talk about different technologies. And today I want to talk to you about furnaces. That's the heating system. So in the government programs currently, the Greener Home program, yes, it is correct. There are no grants for doing furnaces. That does not mean that's not the right technology for certain areas. So if, for example, in Alberta and Saskatchewan, furnaces are one of the better ways to go from an energy efficiency point of view. We can talk later about heat pumps. We have some other videos that we've done on heat pumps and more that we will be adding. So in Alberta, natural gas is relatively inexpensive compared to natural gas. At the current rates today, and we right now at the beginning of, or end of January 2022, the rate on natural gas is about $6.50 a gigajoule, and the rate of electricity is somewhere in 15 to 18 cents a kilowatt hour. That's the rate of everything in. Those are all your taxes, the delivery charges, variable fees, all of those different things. So it's about a $45 per gigajoule for electricity, and it's about $6.50 a gigajoule for natural gas. So somewhere in the region of a 6.5 to 1 ratio. So it's a big ratio difference. The other ones, we can get furnaces now that run somewhere in that 98% efficiency range. So we can burn gas very efficiently. So one thing I do recommend to people all the time, if you have a furnace that's somewhere in the region of around 20 years old, yes, there are no government grants. I fully understand there are no current government grants, and I'm not sure if there ever will be, but there's no grants currently for furnace replacements. Does not mean it's not one of the better things for you to do in your home, particularly in Alberta and Saskatchewan. So if you're going to upgrade your furnace, that's what we need to think about. How are we going to upgrade our furnaces? What furnaces should we upgrade to? And let's talk a bit about furnace selection. So let's go and have a look at this furnace that's installed here, and then we'll talk about furnace selection. Well, here we are, we're down in the mechanical room. I said we'd look at the furnace from the other side. So just a couple of things that point out. This is a high efficiency condensing furnace. How do I know that? If you look at the venting, the white venting, that is what we call CPVC. That is goes directly to the outside. And then the other one is the fresh air intake. So this is what we saw in one of the other videos. This is the fresh air intake of air coming in from outside. Okay, so air goes in, you can actually hear the furnace firing up there. There's been a bit of a heat core. So in this case here, we've got fresh air coming in, it gets burned in the combustion chamber and goes to the outside. So we can't even get combustion spillage on this on the basis that it's a fully closed combustion chamber. I strongly recommend anybody installing a high efficiency furnace, ask your contractor to do a 2-pipe system and not draw combustion air from the space. There used to be a combustion air duct in this room. That's been taken out because it's not necessary, on the basis that we're pulling air from outside. And we also have the same thing on our hot water tank. We will talk about that as a separate video. A couple other things I'll point out while we're here. If you look carefully here, we have on the side of the furnace, we actually have an Energuide rating. This was done a while back. The original, this house here originally had an Energuide consumption of about 190 gigajoules per year. It was changed with the hot water tank and the furnace to 155. A typical new home, about 129. So this house hasn't yet had an upgraded label. This is your ERS version 15. If you want to know more about these, watch some of our other videos. And also go and have a look at the Energuide rating system or energyexperts.ca. So that's where you'll find information. So let's quickly look at what's going on in this furnace, and then we'll talk about furnace sizing. So as I said, we've got fresh air intake coming in. That's the black pipe. The white pipe, that's the vent to outside. It is a sealed system. This one is a Carrier Furnace 58 TP6A. The BTU input is 114 and the output is 111,150. So it's a single furnace, one house. As you can see, the input and output, not a huge difference. This is a 96% efficient furnace. In other words, only 4% is actually going out of the chimney. The rest of it is staying in the home as a heat source. The other thing you can see that the contractor did on this install, you can see all the ductwork joints have been sealed as much as possible, even though this is an older home. That's over here we have our humidifier. Yes, homes in Alberta, Saskatchewan, and other areas with good ventilation, you will need a humidifier, and make sure it's well controlled. That on the left hand side is the humidification control, or humidistat, and that should be adjusted based on ambient temperature. One way to even do that better, have your contractor make sure that that's wired to something like an Ecobee thermostat. That's what I have in my house. That's what I love. Ecobee does a great job on their thermostats, and they will change the humidity automatically. It's called an ambient reset humidistat. It gets wired to the humidistat. Mine hasn't, because I haven't had the chance to do that yet, but that is something I would strongly recommend. But putting on the return air is not a bad way to go, because it gives you a bit of an average humidity of the home. And again, that should be adjusted. So there's our furnace. Just go a few more things on this one here. You don't normally have to know a lot about them, but here on the right hand side, that's your filter. That needs to be maintained and looked after, and make sure that that's clean so you get the fresh air coming through. This is a 2-stage furnace, so let's have a bit of a conversation about furnace sizing and also about selecting a furnace. So what we want to chat a little bit about here is about furnaces, right? We've had a look at how this furnace is installed, what type of furnace we have. It's a high efficiency 2-stage. So when you're going to buy a furnace, bar none in Alberta, one of the best upgrades you can make to a house is installing a new furnace. I strongly recommend people be proactive. Don't wait until your furnace breaks down before you replace your furnace. Go out, get quotes. I always recommend getting at least 3 quotes, but get some quotes, find out which brand, which company you want to work with, and then start saying the features that you want. What is important to you when you're selecting a furnace? So one of the very first things let's start with is what we call furnace sizing. So when we talk about furnace sizing, what we're saying is how much energy is lost from the house when it's minus 30 degrees outside, which is typically the design temperature for Calgary. Maybe it's minus 32 in Edmonton. There's a special number that's used from the building code. It's called the design outdoor temperature. So it's not the coldest day of the year, it's the temperature we would mostly see 97.5% of the time. So that's how a heating system is sized. You say, how much energy do we need to put into the house when it's, let's say, minus 30 degrees, let's say for Calgary, how much energy do we need to put in to match the energy that's leaving? So a well-sized furnace means you're not going to pay too much for the furnace being too big. It's not going to short cycle. It's going to be running almost continuously when it's cold outside. That's normal. So if your furnace runs, you're holding the temperature and your furnace runs for long periods of time when it's really cold outside, you should actually phone up your heating contractor and congratulate him on sizing the furnace correctly. If it's short cycling on and off, the furnace is likely oversized. Typically in history, furnaces have been oversized, so if you're looking at a replacement, talk to your contractor about doing the correct heat loss calculation and ensuring the furnace is correctly sized, which will make it more comfortable, it'll be more efficient, and you'll get the right size furnace. So a heat loss calculation, which is what we call CSA F280, yes, you can contact us at energyexperts.ca and we can help you with that. If you do an ERS, Energuide rating system, through the Greener Home program, there is a heat loss in there. That is still the responsibility of the heating contractor to size it, but it will give you a guide on sizing of a furnace. So now that you've got your size, you know how big it is, and that's BTU per hour, you want to think about some of the other features, right? What you want, single stage, 2-stage, or variable capacity. Single stage is like having an on-off switch and only an on-off switch. What you really want is a minimum of a 2-stage, and maybe even thinking about going to a variable capacity furnace. So that means as it gets a little bit warmer outside, either it'll ramp up or ramp down as it gets colder. It'll adjust the amount of heat coming into the home based on the temperature outside or based on the demand. So a 2-stage will be like a small furnace and a big furnace built into one. So when it's cool outside but not really cold, it's going to run mostly on the small stage. That means it'll run for longer, more continuous periods of time rather than being an on-off cycle. You do want more continuous, so you get a more even temperature in your home. So that's really, really important. I think at minimum you should be a 2-stage, but I do strongly recommend going to even a variable capacity. What brand you go to, I don't really have strong affiliations to any one brand or the other. I have Carrier in this house that I've known for years and years in my industry. They're a great company, but you've got Lennox, you've got Bryant, you've got Train. All the manufacturers make some great products. So talk to your contractor, find somebody you're happy to work with. The next thing you want to make sure of is you want it with a variable speed fan or an ECM motor. Why? Because you want to be able to run that furnace fan on a continuous basis to even out the temperature, better filtration, better humidity control, but you don't want it to be loud and noisy, and you don't want to get those drafts. Please go and have a look at our Hoimi damper video that we're talking about how you minimize those drafts or cold air coming in and improve efficiency. Again, go to look at the Hoimi damper discussion and how you can get those installed. Again, talk to your heating contractor about that. We will talk about heat pumps in another video, so if anybody's got interested in heat pumps, let's look at those from a different perspective later. So select a company you want to work with, Make sure you get a proper heat loss calculation. It's called a CSA F280. Make sure that I do strongly recommend that it's a 2-pipe install. Ask your contractor to make sure it's a 2-pipe if at all possible. Brings in combustion air, gets burnt in the heat exchanger, and then goes straight to outside. It's safer for you, it's safer for your family, and it's a really, really good install. Might make it a little difficult to do the install, but there's always ways to do it. But talk to your heating contractor. Sometimes it may make sense to change the heating, the domestic hot water at the same time as well. But have a look, chat to your heating contractor, and he can help you with the installation of that. So 2-stage variable capacity ECM motor. Make sure it's all wired. Even the fan is wired to the thermostat. I'm a big fan of those ecobee thermostats. You hear me talk about them over and over and over again. And why do I like my ecobee so much? I got one furnace I've got in the house, but I got a thermostat that sits in the middle of the home on the main level. But I've got these little sensors that go around the home that help us to even out the temperature. So hopefully that helps you on selecting a furnace. Make sure you get correctly sized. And I'm gonna actually go and grab, while we're here, let's go and grab one of those sensors so you can see what I'm talking about. And I'll show you the ecobee thermostat. So this is the center of the home. There is the ecobee thermostat. You can see on the wall here. And then this is attached to multiple sensors throughout the house. And therefore, what I do, this is a 2-stage home. What I do with that is, here's my little sensor. There's the sensor that I'm referring to. This is in my kitchen living room area. What I do is I have them upstairs, I have them downstairs, and I can set different schedules, I can average. So think about getting an ecobee thermostat and try and make sure that you have it well controlled. Set your schedules, get to understand the schedules. So if you have any questions, send us an email. Go to energyexperts.ca. As I said earlier on, even though there's no grants, it is one of the best upgrades you can do for energy efficiency in Alberta. And I strongly recommend, if your furnace is around 20 years old or older, seriously think about changing their furnace. Don't forget to go and like us, but also go and have a look at the Hoimi damper conversation that we had. The other thing I just want to touch on before I leave, we'll have a different video on this one when it comes to air balancing. If you've got cold rooms, warm rooms in your house, different things like that, this isn't a function of a bad furnace or a good furnace. This is a function of air balancing. I'll do a separate video later on how you air balance and how you can even out those temperatures. But one of the best ways to start with is the right controls, i.e. the ecobee. The other one is to run that furnace fan more or less continuously, or at least on a schedule. That's going to help you. And if you look around from my house here, you can see we came from a walkout basement. We've got an upstairs. This is one zone, one furnace, one thermostat. And with those controls, we have a much better way of controlling the temperature. So thank you for watching, and hopefully we'll see you in one of the other videos. Visit us at energyexperts.ca. If you're looking for an energy assessment that can help you with a lot of this, go again to energyexperts.ca. Visit some of our other companies, which is Acacia Engineering, mechanical engineering that does full design for new homes and does a lot of these design calculations for our customers. Or if you've got building envelope concerns with moisture, humidity, designing the building envelope, that's our brand called Qualistat, and they've got a ton of videos there to help you with. So go and visit us, and hopefully we'll see you there. My name's Stephen, thanks for visiting us, and we'll chat to you soon. Hi, my name's Stephen. I'm from energyexperts.ca or Vertitech or the VT Group. Today I want to chat to you a little bit about home ventilation. And one in particular, one of the technologies I want to chat about is an HRV versus an ERV. Particularly today I want to talk about the one item behind me here, which is the LD's ERV or energy recovery ventilator. So once your house is really well sealed, you've done a blower door, you know your house is fairly airtight, you want to make sure you've got good ventilation into your home. Why do you need ventilation? You want to make sure your house is healthy, you're making sure you've not got too much humidity, not enough humidity in the home, and a good ventilation system is what you want. But the particular thing I want to talk about on this LD's product, there's the name up there. If you look carefully above me, you can see LD's is the brand that we are looking at here. And why I use this in so many of our mechanical designs is because this has a product called a ZRT or a zone control. So normally with an HRV, if that's your primary ventilation, get rid of your bathroom fans. You know, you want to sit in that tub and have a nice glass of wine, and you don't want that fan making all that noise. One, maybe get a quieter fan. But the alternative is to get something that is in the mechanical room, something like an HRV or an ERV, to provide the right amount of ventilation. But you want to be able to do this in such a way that it's not noisy, so you get rid of the bathroom fans. But when you take, let's just say, an HRV, ERV, that goes from 50 CFM all the way up to 100. What happens is all the bathrooms go up at the same time. So in other words, if you had four bathrooms and in a home, and you went from 50 up to 100 CFM, you would be going from 12.5 CFM each up to 25 CFM each, and all of them go up simultaneously. What I love about this technology from Aldi's is the ZRT. So what they do, it's again, take an example of 4 bathroom fans. Instead of all of them ramping up at the same time, you set each bathroom to, let's make it 12.5 CFM. So that's your 50 when it's at low speed. As you ramp up the speed by touching the 20, 40, 60 minute override, the unit goes from 50 CFM or to, let's make it 100 CFM as a worked example. When it gets to that 100 CFM, instead of them all being 25 CFM, the bathroom that you're in, creating the most moisture and contaminants, will ramp up to, I'd have to work the numbers out, but say in the region around 60, 63 CFM. In other words, the other 3 will be at 12.5 CFM each, so that's 37.5, and therefore the bathroom that you're in would be 63.5 CFM for that one bathroom. So in other words, that one bathroom gets most of the ventilation, the others will stay at the lower one, and this becomes a zoned control ventilation system. So where you've got the contaminants, the moisture, you can control getting rid of it, and this is going to make so much difference. Why do you want to get rid of bathroom fans? I spoke about the noise, but every single bathroom fan that you put into your home is going to have another penetration to the outside. And if you've got a bathroom fan, it's not going heat recovery. So you really want to do something like an HRV or an ERV that you can recover that energy of the air that's leaving with the air that's coming in from, from the air that's leaving going into the air that's coming in. And the difference between an HRV and an ERV, heat recovery ventilators, an HRV, it is only looking at temperature recovery. However, when you talk about an ERV, which is energy recovery, it also recovers some of that humidity. So if you're watching in Alberta, which a lot of our clients are in Alberta, we've got lots in BC, Saskatchewan, Ontario as well, but a lot of our clients are here in Alberta, it's very, very dry. That's static electricity. We need to be able to bring some of that moisture back in. So consider installing something like an ERV rather than an HRV, and really when you look at the controls, make sure you're thinking about something like a ZRT. If you want some more information, please go to the Aldi's website, go and have a look what they've got on the some of the descriptions, some more images. This is a ZRT. This is what it looks like. If you look carefully in the back here, let's see if I can change the way we're looking at it. In the back here, we have a damper, and that is the motorized damper that allows for that control. So the concept behind this is it's a zoned control ventilation system. You don't over ventilate, you get the ventilation where you need it, when you want it. This box behind me, the Aldi's product, we're sitting in your mechanical room, which makes it really quiet. We're sitting here in my office in Calgary. That's where I am right now, just so I did talk a little about this as we can see the product. So if you like this is helpful, please go to their website, Aldi's, to the website, look at the link below. Remember the ZRT and why you want to ventilate. Lots of other videos hopefully to help you understand how to ventilate, different types of heating systems, lots more to come as well. So thanks for watching. Please go to energyexperts.ca. Again, my name's Stephen. You can find us at energyexperts.ca. Click on the link below. The other thing is obviously go and have a look at Acacia Engineering. When we do mechanical engineering for residential, we do a lot of high-end homes. This is typically what we're putting in those, and we normally put those with the hydronic heating system, which you can see in the background. That's the best way to go. Again, thanks you for watching. My name's Stephen, and please share and like this video. If you like friends or family who should know more, please share this with them.